Hello again, physicists. Today I have a video for you. It is about artificial gravity. Now, if you're a fan of science fiction movies like Interstellar, the spacecraft, oftentimes you may notice that they're spinning. So here's a still shot of the spacecraft used in the movie Interstellar. And you may have noticed that as they were traveling through space, the craft was traveling in a circle like that. And the reason for that is that it was actually creating artificial gravity. Today, we're going to use the concepts of circular motion to show you how this science fiction is actually not so much fiction. This is a real principle that can be used to generate artificial or apparent gravity while traveling through space, even though the spacecraft may not be near a large object like a planet or a sun. So to begin thinking about what has to be going on inside the spacecraft in order for there to be simulated gravity, let's take the image on the far right to be kind of the inside of a circular spacecraft, like the one from Interstellar, and then the people would be on the edge of the spacecraft. And keep in mind that the entire thing is rotating like so. That means the people inside the spacecraft are undergoing circular motion. They are traveling in a circle like this. Now, if we drew a free body diagram showing the forces acting on this person, there would only be a single force acting on them, and that would be the normal force of the spacecraft, some edge or surface of the spacecraft, pushing against the person. And this force would be a centripetal force. It would be a center-seeking force that points towards the center of the spaceship. This normal force is going to be our gravity. This is our simulated gravity right here. And we know that if we were talking about actual gravity like on the Earth, that would be the mass of the person times their acceleration due to gravity. What I'm going to do in a moment is I'm going to actually swap out normal force in Newton's second law, and I'm going to replace it with the mg that we would use to calculate someone's force due to gravity on Earth. And this will allow us to think about how do certain aspects of the spacecraft determine how much of a simulated gravity there is. So here we go. Now, circular motion problems start off like any sort of problem involving forces. We're going to use Newton's second law. A is equal to F net over m. However, with circles, we have to remind ourselves that this is a center-seeking acceleration, a centripetal acceleration, and that will be equal to the net force pointing towards or away from the center of the circle divided by the mass of the object that is traveling in a circle. And we saw from class that the centripetal acceleration is dependent upon the velocity of the object squared divided by the radius of the circle. And that will be equal to the net force pointing towards or away from the circle. In this case, the only force pointing towards or away the circle for a person in a spacecraft would be that normal force from the prior slide. And that will be divided by the mass of the person. All right, we're almost there. One last step. I'm going to keep everything the same, but I'm going to replace this normal force with the way we would calculate someone's gravitational force if they were on Earth. Because remember, this normal force is the force that's going to be simulating the person's gravity. So when I make that substitution, you'll see that the mass of the person drops out. And if I rearrange this so that I have the acceleration due to gravity solved for, we can see that the simulated acceleration due to gravity will be equal to the velocity of the spacecraft, how fast it is rotating, as well as the radius of the spacecraft from the center to the edge of it. And basically what this means is if the spacecraft spins faster, the simulated acceleration due to gravity will also increase. it also means that if we make our spacecraft so that it has a larger radius, it will increase the apparent acceleration due to gravity. And that's how you can make gravity in the middle of space. Until next time, physicists, until next time.